All right, so this is a quick review for the quiz that we're going to have on Monday. We're going to start with doing a few examples of simplifying radicals. So let's start with square root of 28. So that's not a perfect square, so you're going to do a factor tree. So 28 is 7 times 4, and then my 4 is 2 and 2. So I have two 2's, which is enough to make a group. So pull those 2's out, and then 7 is left over. So 2 root 7. Okay, now if it's not a square root, and maybe like if we do a cube root, let's say cube root of 40. So 40, do a factor tree. So 4 and 10. So 4 is 2 and 2. 10 is 2 and 5. So we have enough 2's to make a group. Since it's a cube root, we need a group of 3. So the group of 2's come out. The 5 is left over. It's going to stay under the radical. Okay, now if you have variables, so let's do the 4th root of 16, x to the 5th, y to the 12th. No, let's change that. Let's go y to the 14th. Okay, so 16 is 4 times 4, and then that'll break down into 2's, and we do have a group of 4 2's. So we have exactly the right number to make a group. Okay, now the x's, you have x to the 5th, so you need 4 of those to make a group, and then you'll have 1 x left over. Y to the 14th, we have y cubed, so that would be to the 12th, and then you would have 2 y's left over. So there's your simplified version. Okay, you can also multiply and add using radicals, so let's add first. So I have 3 root 11 plus 4 root 11. Since they're like terms, we can add those together, and that will be 7 root 11. Okay, if your radicals don't match, so let's say square root of 7 plus 4 square root of 56. Okay, so those radicals don't match, but let's see if I can simplify the 56 and find something that I can take out. Okay, so 56 is 8 times 7, and then the 8 is a 2 and a 4, and the 4 is a 2 and a 2. Okay, so square root of 7 plus 4. So this is a square root. So I can take 2 2's. So those 2's are going to come out, but what's left over is a 2 and a 7. So that's going to give me 14. So root 7 plus 8 root 14. So we were able to simplify a little bit, but our radicals still didn't match. So this is as far as I can go with this one. Okay. All right. Multiplying with radicals. So if I have negative 2 square root of 7 times square root of 7, okay, I can multiply those together. So my coefficient on this one is kind of like a 1. So you can think of it as negative 2 times 1. And then root 7 times root 7. Well, that becomes square root of 49. Well, that's a perfect square. So this would be negative 2 times 7 or negative 14. Okay. So that was nice. That simplified as a perfect square. All right, let's do a couple more with multiplication. So if I have 3 square root of 5 times square root of 10. Okay, so this would be 3 and then square root of 50. So again, we're going to do a factor tree to see if we have any pairs pop up, and we do. We have a pair of 5's. So I have a 3, my pair of 5's can come out, and then root 2 will be left over. So 15 root 2. Okay, number 8. You can also distribute with roots. So if I have 3 plus 4 root 15. Okay, so I can distribute. I can do the root 5 times the 3, so 3 root 5 plus 4, and then 5 times 15 is 75. Okay, so now I'm going to see if I can simplify that 75. So that's, you can go the 15 and the 5. I was just thinking 25 and 3. 5 and 5, and then I have this 3. So I have enough to make a group. So 3 root 5 plus 4 times my group of 5s, and then I have 3 as a leftover. So 3 root 5 plus 20 root 3. So again, the roots don't match, so this is as far as I can simplify. If they had matched, then I'm going to go ahead and add them together. Okay, so moving on to kind of our next topic is rational exponents. So your rule for rational exponents is a over m to the n can be rewritten as the nth root of a to the m power. Okay, so, and we can convert back and forth. We can go from a rational exponent to a radical, or we can convert a radical to a rational exponent. Okay, so let's do x to the 4/7 power. So to rewrite that as a radical, your 7, that denominator is going to become your root. The numerator is going to become your exponent. Okay, so here, this is going to give you 7th root of x to the 4th. Okay, 7th root of x to the 4th. Okay, next one. If we have p to the 1/5 power, same thing. So the numerator is going to become your exponent. The denominator is going to become your root. Okay, so here this is going to be 5th root of p to the 1st. You don't have to write the 1, so you can write it just 5th root of p, and that's the same thing. Okay, so number 3. Okay, if you have, let's say, something like 2x to the 2/3 power, rewrite that as a root. Well, okay, so it's going to be the root of 2x. It's going to be a cube root, okay, because your denominator becomes the root. The numerator becomes the exponent. So 2x squared. And you want the parentheses because all of that is getting squared. Okay, now you can simplify this if you want to, because if I square that 2, that's going to become the cube root of 4 and then x squared. So either one of those is correct. However, you cannot write it like this, okay, because then you are only squaring the x and you're not including that 2. So that is not a correct statement. Okay, let's do one more of these that looks like this. Okay, so let's do this. Let's do x to the 7/4 power. Okay, so write it as a root. It's going to be the 4th root of x to the 7. Well, look at this. Since it's a 4th root and you've got x to the 7th power, you have enough to make a group of x's and pull those x's out. So there's a group of x's that's going to come out. And then what I have left over is 3 of them. So it's going to be x 4th root of x cubed. Okay, so when you do rewrite that as a radical, if you have enough to make a group of something, go ahead and pull that out and simplify. Okay, now let's go the other direction. So what if you have the 3rd root of x squared? Okay, now rewrite that as a rational exponent. Okay, so we're just doing the reverse of what we did before. So that root came from the denominator. The exponent came from the numerator. Okay, so if I rewrite this, this is going to be x to the 2/3 power. Okay, let's do one more of those just so you can see it again. So if we have, let's say, the 5th root as 7x to the 3rd power. Okay, same thing. The root is going to become the denominator, and then the exponent becomes the numerator. So there's that one. Okay, one last item to look at is we also did a little bit of solving. Okay, so x to the 4th equals 162. We'll try this. Okay, so x to the 4th equals 162. So you're going to do 4th root of both sides. Okay, so this is going to be x equals, it's going to be plus or minus the 4th root of 162. Okay, so if it's an even root, when you go to take the square, like square root or 4th root, if it's even, you're going to have plus or minus. If it's odd, you will just have one solution. Okay, so let's do a factor tree on 162 and see if there's anything we can get. Okay, so this is going to be 2 times 81. 81 is 9 and 9. And then I've got some 3s. Okay, and then this 2 comes all the way down. All right, 4th root. So I've got a group of 3s. So I go plus or minus 3 4th root of 2. Okay, so there's 2 solutions for that one. Okay, so let's do another one. This time, let's do x minus 3 cubed equals negative 84. Okay, so we're going to go cube root, cube root, cube root. So I get x minus 3 equals, okay, now cube root of a negative. Since it's a negative and an odd root, I can pull that -1 out. Oops, sorry about that. I can pull that -1 out. So this is going to be negative cube root of 84. Okay, so then I can add 3 to both sides. So x equals 3 minus cube root of 84. Okay, now that 84, let's do a factor tree to see if there's anything in here we can use, and there's not. Okay, so I can't really simplify that anymore. So this is your answer. Okay, now a couple other things real quick before we finish is these are answers in simplest radical form. Okay, so if I ask for simplest radical form, this is what I'm looking for. However, you could also give these as decimal approximations. Okay, so let's take a minute. Let's look at your calculator to remind you how to do this on your calculator. So, okay. So this first one, plus or minus 3 times the 4th root of 2. Okay, so you're going to do 3. And then to get that 4th root, that is with your math button. Okay, so math, and then it's number 5. Okay, so it's the x root. Okay, so now since this is the 4th root, I need to go back to my home screen. So I have my 3. Oops. I have 3, but now I need times the 4th root. So since I want the 4th root, I'm going to use that x